Audio check. Hello and welcome to the stream. We'll be starting here in just a moment. I've got some interesting drum beat going on right here. This is making use of a couple of different modules. Two of my drums are coming from the Erica Synths Pico Drums module. Two of them are coming from Momo Modular's clone of Mutable Instruments Peak, which is an open hardware and open source module. And the other two drums are coming from a clone of Mutable Instruments Platts. But today I'm going to start by unpatching and start with a blank slate, and we will build something up while I explain some pieces of this synthesizer. So I'm just going to take some cables out here. Wow, I didn't quite mean to pull the main clock so quick there. Well, we'll just keep going. Okay, that's relatively clean. I'm going to start out by giving a tour of the modules I have. Let me change the camera just a bit here to get a closer shot. Okay. So first of all, I will start with sound generators. I have Platts, which is an oscillator. It's a complex digital oscillator with many different sound engines built in. You can push a button to switch between different modes. I also have a rather inexpensive Behringer 112 dual oscillator. There are two oscillators together here on one module. I also have a complete Behringer Neutron semi-modular synth that is on my upper row above what's currently showing. I'm not going to be using that today, but it does some amazing things, and I will use it in the future. But I'm focusing on modules in the Eurorack format right now, and that's kind of a standalone, so just be aware that it is there. It also has sound sources. I also have some drum modules. The first one I have is Drums by Erica Synths. It's this little 3 HP wide module in their Pico series, and that can generate 2 drum sounds simultaneously. It has samples of drums, and it's selectable what the 2 drums are. I also have a clone of Mutable Instruments Peak, and it is it's a multifunction module, and one of its modes is a drum generator. In many ways, it's very similar to the Pico drums. And that's it as far as sound generators, at least those that are intentionally meant to be. It's possible my filters might be able to self-oscillate. I haven't tried that so much with these ones. Okay, so the next type of module I have are low-frequency oscillators, which are used to generate control voltage signals that can be used to control the parameters on other modules. And so I have the very popular Instro Oct, which is designed by DivKid. It has 8 LFOs all on one module, and they are kind of chaotically desynchronized from each other. They are set up so the faster waves are on the top and the slower waves are on the bottom, and there's one knob that can be used to adjust the overall speed, and there's also a CV input that can be used to control all 8 LFOs simultaneously. I also have a quad LFO by Doepfer. It is the A145-4. And in my particular setup, I have the top 2 unjumpered, which makes them run at a higher speed. and the bottom two are in their jumper configuration so that they are a much slower range. There is some overlap between the two ranges. If you take a look at the LEDs blinking, I think those are visible to the camera. You'll see the bottom two are blinking at their fastest rate right now. Actually, that might just be not quite be visible. Maybe if I put my hand there, you can see them reflect off my hand. I'm not sure. Anyhow, the top range at its lowest is overlaps with the lower range when it's set to its highest. So there is some overlap there. And this generates 4 individual triangle waves and 4 individual square waves running at the same speed as the triangle. I also have envelope generators, which the ones I have here are loopable, so they do function similarly to an LFO. I have a bank of 4 connected in this module from Rides in the Storm called the QEG, Quad Envelope Generator. And I also have 2 single modules from them in the upper row here. Those ones are the flexible envelope generator. After that, the next type of module I have are filters. And currently in this case, I have the A1065 SEM style filter from Doepfer and the A124 VCF5 WASP filter, also by Doepfer. And then I have several utility modules. I have a clock divider. I have a ring modulator, sample and hold, and slew module. I have a voltage control panning module. I have an attenuverter / attenuator with 2 channels. I have 2 quad active multiples. I have a dual no gain mixer. I have a 3-channel attenuator that I made myself. I have two mini stereo mixers from Doepfer. They're both the A138S. One of them I'm using in my output chain, along with Rides in the Storm Con, which is their gain converter. I also have the Quad VCA that Behringer makes. It's a clone of the IntelliGel Quad VCA. I was actually looking for Mutable Instruments Veils and would have preferred to have the new variant of Veils. But because Mutable Instruments is no longer producing new modules, and clones of that particular module are scarce, I wasn't able to find one. I also have another module I built myself called XBus. It's just an external bus access module to be able to use to test modules outside of the case. Let's see, what else haven't I covered here? I have dual voltage control switches, 2 HP arpeggiator, and the Erica Synths Pico trigger generator right up here. I also have velcroed onto the side of the case here this utility called cv.ocd. It's a MIDI to CV converter. And I know a lot of this probably doesn't mean much to some of you, those just getting into modular who have no idea how these things work together. So I apologize about going over all those in so much detail right up front. But now let's go back to basics, and I'll start with some simple things. So the basic idea here is that we want to take some sound and shape it and output it. So I'll start out by taking a signal out of the Behringer 112 oscillator, and I will plug it into the output directly. Let me turn the volume down first. Okay, now I'll turn it up. See if I can get something coming out here. Oh, I don't have that mixer hooked into the other one. That's fine. I'll plug it into this one. Okay, there we go. That's currently panned to the left. I'll put it on the center. Okay. So this is the sound of the 112 oscillator running in pulse wave mode. And the oscillator has a pulse width option built in. Sounds like this. It also has a knob to adjust the octave. And a fine-tuning knob. It also provides other wave shapes. I'm going to switch it to a sine wave. I'm going to turn it up to a higher octave. It's a much gentler wave. And it also supports a sawtooth wave. So, by itself, an oscillator is a little bit boring. It just makes a sound. And what we'd like to do now is sculpt this a little bit. So instead of running directly into the output, I'm going to run it through the SEM filter. So I'm going to unplug the cord from the mixer, and instead I'll plug it into the audio input on the filter. And then I'm going to take the output from the filter and plug that into the mixer. And we'll turn the volume level up on the filter. and on the mixer. Oh, why am I not hearing this? I must be doing something wrong. Audio in. Levels up. Okay, there we go. Not sure why I wasn't hearing that right at first. Did I have it up too high? I'm not sure what that would even indicate. Okay, so here is the sound coming through the filter. And the filter allows me to control a cutoff frequency. So what that means is everything that is higher than the cutoff frequency will get eliminated from the sound. So I'll just turn that down right now. And back up. And down. And let me change the tone to a higher octave. And make sure I'm on sawtooth. Yes. So the next thing a filter can do is it can provide resonance. Basically what that means is the sound right near the cutoff pitch gets amplified while the other frequencies remain the same. Those above the cutoff pitch are eliminated. So let me turn resonance up. And then I'm going to change the cutoff frequency so you can hear what that sounds like. And I'll turn it up even more. Resonance is now all the way up. Okay, so now we've covered an oscillator, also known as a VCO, voltage controlled oscillator, although currently we are manually controlling it just by turning the knobs on the module. We're running it into a voltage controlled filter. Let's talk about this voltage control business for a moment. So as you've seen, if I adjust that cutoff frequency, it sweeps through those frequencies. But what if I want that to happen automatically? Well, all I need to do is run a chord from one of the low frequency oscillators into the input for the control voltage. And now it's modulating automatically. And I can adjust the speed of the LFO so that it controls that at a lower rate. Now, if I don't want it to sweep through the whole range, I can actually turn down my CV attenuator. Wow, I feel like this is just not working right. What did I do wrong here? CV2 input. If this knob's all the way down, that really shouldn't be doing anything. I wonder if my SEM filter is damaged in some way. This was the one that when I first plugged in earlier, it was completely silent. I'm a little worried about it. I don't know what to think about that right now. You turn the resonance down. Because usually, if usually if something's going into CV2 and there is no level on this CV knob, then the CV2 wouldn't be doing anything. But I can clearly hear it making a change. Very interesting. Haven't run into that before. I'm going to try switching to the other filter just to see what happens. You turn the levels down on that one. It's arranged a little differently. Audio in here. Output here. CV2 here. And I bring the level up. See, okay, this one's as I would expect. And now as I adjust CV2, yeah. So then if I turn the CV knob down, it should go back to being stable. Yeah, that one looks like it's behaving. Okay, so let's see here. The next thing we might be interested in is making the notes stop and start so that it's not playing a tone all of the time. So the classic way to do that is to run it through a VCA, a voltage controlled attenuator. And so what we would do is, instead of going directly from the filter to the output, we run the filter into the input on our attenuator. Then we would run the output from the attenuator to the output. You'll notice there's currently no sound. Okay, so we need to also provide control voltage to let it know when we would want the note to play. And I will go from one of the envelope generators here, and let me adjust some settings on that. And I should be able to fire it by pressing this button manually. There we go. So I can make it taper off more gently. And I can also adjust the type of response. There we go. And if I just wanted that to go at a steady pace, I could slow down one of my other LFOs and then use the square wave output from that LFO in order to trigger the envelope that we just configured. And there it is. So now that's better, but we're just carrying the same note over and over and over. So let's make that more interesting. I have an arpeggiator, which is probably the easiest way to get some pleasing musical pitches happening. So I'll take the output from my arpeggiator and I'll run it into the pitch input for the oscillator. And then instead of just triggering the envelope, I also would like to tell the arpeggiator to move to the next note. So to do that, I need to split that trigger. I'll use one of these mults for that purpose. And I will run from the output of the mult back to the input of the envelope generator. And then I'll run another patch cable from there to the trigger of the arpeggiator. And let's tame this by turning down the resonance and adjusting the filter a little bit. There we go. Okay, now let's get some movement going. I'll take one of the LFOs from the oct module and I'll run it through my attenuator so that I can control how much of that we're getting. And then I'm going to take that and I'll run it into actually, instead of going through my attenuator, I'll just go straight into the CV of the filter. Then I'll turn the cutoff and change the speed of that. I guess I was already controlling that one with the dope for LFO. Let me just move it to oct. I don't need to be doing that twice. Okay. What I could do instead with the signal from the dope for LFO is I could control pulse width modulation and make this be a pulse wave. There we go. I guess the next obvious thing to do for me would be to run into the input of my clock divider from the trigger that we're using, that we already have in the mult. And then I can go from one of the clock divisions into the trigger of my sample and hold module. This will cause it to generate a new CV every 16th trigger, I think. Then I'll go from the output of that into the root of the arpeggiator. And let me adjust the arpeggiator's settings a little bit here. Quite hearing what I was expecting from it. Let's see. Sample and hold. Let me give the sample and hold an input source. And I'll just go from one of the other oct LFOs. Here we go. Let me turn that down. So that's way too wide of a range. So if I want to narrow that down, I could run it through Tool. So I'll just plug into channel A on Tool. Then I'll go from the output of Tool to sample and hold input. And I'm going to speed it up a bit just so I can check this range. Okay, that seems reasonable. I'll turn it back down. So now I noticed that when it changes pitch, it's changing halfway through the arpeggio sometimes. So we could probably fix that. All we need to do is once again split the signal, and we'll run it into the reset of the arpeggiator at the same time as we run it to the sample and hold trigger. So instead of using a mult, I'm going to use a stack cable for this, or a splitter cable. So I'll just take the sample and hold trigger, which I believe is this one, and instead I'll plug in my split cable, plug the trigger into that, and the other end of the split cable into the reset. And we're probably going too many steps before each reset. So on the clock divider, I'll move this up one. different clock divider settings. Let me play around with those. Different arpeggio modes, different chords, and different patterns. I don't know how all these settings work honestly yet. Cool. So now, instead of going directly into the output of the mixer like we have been doing, I'm going to run through an effects module. And let's see. To do that, what do I have here? I think I just would plug it in right here. And this has quite a few different effects I can choose from. If I can find the button. that's pretty nice. Let's step it up one more level. The way we'll do this, I'll take the output that we are currently using to feed the root of the chord generator, and I'm going to actually split that and also feed the Platts oscillator with the same, instead of Platts, I'll just feed the other side of the dual oscillator we're currently using. I'm going to use a split cable for this. So let's see. We'll take the output from sample and hold. I'm going to unplug that. And I'm going to plug in the splitter. And attach the original cable back to the splitter. And then I'll run the other end of the cable into the other oscillator. And it looks like I have the arrow on this knob pointing the wrong way. Maybe attach this the right way around so it's less confusing. Okay, now that oscillator needs to be going somewhere, so let's just take another patch cable and we'll run from the output of that oscillator into one of the other channels on my VCA, which has mixing capability as well. And I'm going to change the settings on that channel. And then I need to make sure these are tuned together. Now you notice that one's not running through the filter, through any sort of filter, so it sounds really harsh and overbearing. I'll go ahead and put it back through that first filter we were using instead. Hopefully that filter's working okay. So let's see. We'll go to the audio input there, and then we'll go from the output there into the quad VCA. I want to give a shout out to Kay Arla for tuning into the stream today. And a shout out to Angelica Starlux. Now let's try adjusting the speed of this a bit and see how it sounds. Today's mystical thought pertaining to the Kabbalah. Sefer Yetzirah describes that there are three mother letters in the Hebrew alphabet: Aleph, Mem, and Shin. Shin is said to be above, Mem is below, and Aleph divides and balances between them. Shin is a sibilant sound characterized by the hissing of air between the teeth. Mem is a mute sound, vibration going through the closed lips. And Aleph is an aspirated sound of breathing. We can achieve hissing sounds depending on the types of waveforms we use, and filters and resonance. We can also switch to sine wave and reduce resonance. And make a mute sound. Does a synthesizer breathe? Does it inhale and exhale? I hope you'll join me on Wednesday for my next stream. This has been Daughter of Voice.